Hey guys, this is Robert with FabTech Solutions. Today we're working on a Cincinnati Shear. We're going to be diagnosing a problem they're having with their back gauge back here. They were saying that the back gauge, as they were calibrating it, the back gauge came all the way back. It went past its limit right here and actually hit the back of this ball screw and pushed this guy out. Now, me coming over and looking at it before I started the video, this guy, I was able to hit it back in with my hands. Now, not ideal. You don't want this to be moving like this. If I go to the other side, it's nice and tight. So we'll get into that. But first things first, right off the rip, if this is going past its limit right here, there's most likely a problem with this limit switch. Now, if I come over here and I push this in and I get real close to it, I don't hear this clicking like a normal limit switch should. Could be stuck, it could be wore out. This style of limit switch is sealed on the inside, so you can't get to the contacts in here. So the next best thing we can do, we do have a panel right here that we can look into. The limit switch goes directly into, or the cable that it goes into goes directly into this panel right here. See stuff like this, something's probably cut it in the past. I can feel wire nuts back here. So you have an attachment point in here, right here. It looks like it's been broken here before. You have wire nuts right here. So there's multiple places that this can go wrong in this current setup. So we'll see what we can figure out. So just for argument's sake, I'm not gonna get up under here to do this. I'll take it apart right here. I can electrical tape this back. Things like this get crusty all the time, sticky. The glue separates when you have oil and glue material. This is not ideal, guys. If you end up cutting through lines like this in some way, don't use wire nuts. Use crimps, use spade connectors with shrink wrap. That's going to ensure this does not get to this point. All right. Now that my hands are covered in this sticky mess, it's on a trash can. So, limit switches. They usually have 3 or 4 wires. You can either have a dual channel one, to where you have 5 wires going into here. Sometimes you might have 4 for dual channel. We'll have 2 hots and a neutral, 2 hots and a neutral. So when you press this switch in, it completes the circuit. Machine knows where this arm is at. This one, it has a hot, a neutral, and a ground, which is fine. Just take note of what wire goes where. So green's going to green, black's to black, white's to white. And you can tell this has been here for a while. When we go back together, we're not going to be using wire nuts. We're actually going to be crimping some connectors on here to where it is a more secure connection than wire nuts. So now that we know what the color code is on this, we're just going to take these off. We're going to re-terminate that, so not too worried about it. We'll take our multimeter and we'll check to see if we get anything. You can use alligator clips for this. Probably be better so your lead doesn't fall out. So depending on the configuration of this limit switch, it can either be a normally closed or normally open. Depending on what it is what's going to determine what this multimeter says. So right now we're not getting anything. Push this in. Look at that. We got some ohms. So that limit switch is working correctly. So this one you would call a normally open switch. You don't have continuity when the switch is open. When the switch is closed, you see up on the screen, we now have 3 ohms. Could be more, could be less. I would say that this switch is suspect because of the jumping ohms as it is right now, but sorry for another day. Continuity test, beep it at me. That's all right. We'll make sure this isn't shorted from one leg to the other. Put my lead back on here. Not shorted, which is good. Not shorted. So we're back to our normal ones. Got a beep. So I would say that this limit switch is working correctly. So we will be going back together with some connectors, some shrink wrap to make this a lot better than its current state. For now, while we're testing, we will hook it back up normally. We'll be hooking it back up the way it was just for testing. Next, we're gonna go on this panel right here. That guy off. It's not supposed to come off like that, but let's get up in here so y'all can see. All right, let's look in here. So, you get your cord coming up, go to the bottom. This is your limit switch right here. So we have your ground, your green wire going up to your ground terminal up there. You have your black wire, which are two. That's interesting. Goes up into here. Safety circuit goes through this right here. It probably goes up into this panel up here. It might run to the other side, because I don't see an exit unless it goes right through here, up this wire right here, in here, out that way, and then to the panel, because I don't see any other wires coming out of there. Guys, when I have this panel open, I'm also looking for any burnt contacts, any burnt relays, components, anything like that that's going to jump out at me that might cause an issue. Don't see anything off the rip. I don't see any burnt contacts in there. Everything looks pretty normal. Let's follow that wire. So we got your wire comes up into there. This is the only box coming out. I don't have my pointer today, but this is your conduit going up to your control panel right here. Now, I'm gonna manually run this guy back and see what it does. Just make sure everything's out of the way. You can actually see your ball screw down in there. They have these covers broken off. Same thing with this one. This one's gone, it's broken off. Let's see what happens. So, we will move this guy forward. And I'll actually look back here to see if it's moving. It's not moving. So, let's see here. Look at that. Got a little light up there. One light. I'm looking through this hole right here at the back gauge to see if it's moving. Well, it's not moving. Let's see here. Have you tried turning it off and back on? Main disconnect right here. Turn it back on. Let's move this guy back. I just need to see if I hit this back gauge calibrate button, is that gonna come back? Right now, we don't have any movement on our back gauge. This is your back gauge motor right here. I'm looking at this back gauge to see if it's moving. I hear it trying to do something. Turned off. So, when I come up here, I'll press calibrate the back gauge. I can hear that's clicking on. If I hit this limit switch, I hear it unclick itself. So that's telling me, normally these have a brake internal to this motor. Sometimes there might, sometimes there won't be. Most of the time on a back gauge, there is not a brake in here for your X-axis movement right here. Your R-axis, your back gauge moves up and down. That's where your brake comes into play. There will be some resistance, so you don't hit this guy, move it as you're putting material in here. But that motor is not turning on, so we'll have to get into that. So follow your motor, comes out into here. Let's come all the way back around and come up to the top right here. So we're back into this box right here. So we have a logic board right here, relays. I may turn the power off and take these relays and swap them around. But before we do that, this is a rarity with these old machines, but it actually has a manual. So we'll go through, see if we can find electrical schematics. I'm looking for a full electrical drawing. This seems like what I'm looking for. Let's see. So what I'm going to do, with this still powered on, we'll take my leads. I'm going to see if this motor is getting any power to let this back gauge move. So I don't want to be inside of there while this machine's running. Always safety first. Let me actually close that guy up. So you have to figure out if it's going to be AC or DC. Most of the time, your motors are going to be AC driven. If it's 3-phase, this one, I'm looking up in the panel right here. Be careful not to touch anything. There are 4 wires. So you have 3 hots for your 3 phases, and you have a ground. So that tells me that this is a 3-phase system, which means that it is a AC motor. A look at the drawing. This back gauge is a DC back gauge motor controller. Just because that says DC does not mean your back gauge motor is DC. Just the panel itself is DC. We'll go in here. First off, remember what we said earlier. A1 and A2 is your back gauge motor. A1, A2, B1 and B2 is your brake. So we're testing A1 and A2, which would mean this is a DC motor. So we'll change our voltmeter over to DC. In between A1, be careful when you do this. Always, always, always be careful. Right now, there's 0 volts. I will turn this back gauge on to calibrate. I heard the motor release. Are there any volts between that? No, they're not getting any volts at all. Compared, if I hit this again, I test B1 and B2, which is your brake. I should have something. So what I'm seeing is that the motor is not receiving any power at all. Next step, we're going to be turning the power off, and we're going to be taking these relays right here off, and we're going to look at it to make sure we don't see anything out of the ordinary. So turn your motor off. Turn your main power off. Well, let's see if we can get these relays out. Just taking these tabs out. Remember what order you take these out with. They might have different part numbers. Get a little wiggle out. Look this guy over pretty good. Set him aside. That's the top. That guy out. Clean the dust off. Inspect him. It looks pretty normal. Number 3. Inspect him. He looks pretty normal. So what I'm going to do is I'm going to see if these are interchangeable with each other. Looking at the part number, they all have the same part number. They are interchangeable with each other. Keep that in mind. These relays, K1, K2, and K3. Let's go see what our drawing says. Let's see if we can find K1, K2, and K3 on here. Didn't find anything that says K1, K2, and K3, but since they are the same part number, interchangeable in this orientation right here. So number 1 goes back into the number 1 spot. Number 2 and number 3. It's all in there. We still have to put these back in before we're done. Still no movement. No voltage. No voltage. Let's press it again. No voltage. No voltage. So we can safely say those relays don't have anything to do with this motor. So, just kind of looking at this, there is a circuit breaker right here. I don't know if you can see that. It says it's off. So what I'm going to do is I'm going to turn the power off, turn that on, turn the power back on. Power's off. Make sure that there is no not tripping itself. This guy seems like it feeds power to this board up here. That's probably your ground, your neutral. Also feeds power somewhere else. That's about the incoming power. But we'll see. Power back on. Look at that. We have power. Was not there before. So, well, we'll see if this guy will move. Hear that? That is your fat gauge motor moving. So, we now have power. However, you still have no movement in your back gauge. See if this is tensioned. This is very loose. Very, very loose. So, can't tension it any more than it already is. It's pretty maxed out, if you can tell right here. So let's go up under here and see if we can see anything that might be holding it up. So, I don't see anything up, you're just holding it up. Remember I was talking about that brake. So if I take one of those brake wires up there off, I should be able to disengage this brake and let this guy move. Let's see if the brake is disengaging when I hit this button. It is disengaging. However, they're still having issues. It's like this guy's bound up. With there being no power on this, we should be able to manually, that one moves. I'm looking inside here, with the ball screw move. You can barely see it moving. Same thing with this one. That one is jammed. So what I'm gonna do, get that belt off of there, even though it's probably not doing much at the moment. As you see, this, there is no brake on it right now. Actually, if I pull on that belt right there and look in here, the back gauge is moving. It's not jammed. So I just need to get new belts on there, which seems like this is a newer one. It might be a different size. Let's look at the number on here. So we have a 55J on here, 550J, 550J. Let's look at the length of it, which I see is down here, 17076. Well, there's not a length on there, but seems like with a dry fit, she'll still fit. But you never know, this might be the old belt. Looking at the condition of it, it seems like it is the old belt. Crack right here. This is definitely the old belt. So they have this piece of metal in here. That's supposed to be for tensioning. As you see, it is not very tight. Even with me doing that, it's already, make sure it's not hot, it is already tighter. So we might have to find some more material to put in here. Or we can loosen these bolts right here. This one, and actually slide this whole assembly back. We're going to be loosening this bolt, and physically moving this mount backwards 5/16. Loosen that one. Loosen this one. This whole thing should move, I don't know, freely, but it should move now. It's like that. So we are going to do our best, one, to keep this thing straight, how loose that is. Keep this thing nice and tight. Tighten your bolts back up. Step 2, throw your flashlight in the floor. That's usually always a good step to use. Oh yeah, it's nice and tight. Turn everything back on and we'll see what happens. Look at that. Back gauge works like a charm now. It's been zeroed, but we're gonna go up and we're going to use the manual buttons right here. I'm gonna look through this hole. I see that it is moving. Trying to see how smoothly it's moving. Seems like it's okay. So we're going to recalibrate this guy. May have to turn it back on and back off in order to get it to recalibrate. Seems like it's pretty smooth. Make sure I have a handle stop button. Okay, put their belt back. Just checking to make sure I don't see anything that's moved. Seems pretty normal. Let's see. There it is. I put it at 10 inches. We'll see if it's 10 inches. Okay, it says it's at 10 inches. Let's find out if that's true. See right there, it's all 10 inches all day long on this side. Let's move over to this side. Make sure you don't hit your head on anything. 10 inches all day long, look at that. So we'll test her out. Well, actually, this got a 2 inches. Gauge position. 2 inches. Enter. And we'll hit start. There's our piece of material we're going to shear off. Get it up. Get your bag gauge. Hit your pedal once. We get our piece of 2-inch material, about 60,000, about a 16th-ish. So we'll see if that's good with the customer. So guys, we just got customers A-okay on this machine. So we're gonna put these clips back in, we'll put this panel back on, and we are going to get some connectors for these, so we don't have to use wire nuts. Thank you guys for coming along on this repair for the Cincinnati Shear. Again, my name is Robert with FabTech Solutions. We service and sell metal fabrication equipment. Things like shears, metal bandsaws, press brakes. There's a laser over there. Anything you guys need, you let us know. We'll see you on the next one.